start with a quick overview of where we cheer. So far we've done linear functions, quadratic functions, polynomials, logarithmic functions, exponential functions, trig functions. We just did functions. Now we're moving on to this function, which is called rational functions. Okay? We see that the functions differentiate by their end behavior and their domain and range. Okay, so with a rational function, big picture rational function, okay? A rational function is generally shaped like this. We notice it has two asymptotes, a vertical asymptote and a horizontal asymptote. And what we're happening here is that the domain, which otherwise would go from negative infinity to positive infinity, has a break at x equals 3. It goes up until it then doesn't exist at 3, but then continues on after that. We notice that it also has a break. The range also goes from negative infinity up to 3, takes a break, and then continues on for positive infinity. So, rational functions. What causes these breaks, and how do we know versus, let's say, a linear or trig function? Well, rational functions are always this is the parent. Okay, y equals 1 over x. So rational functions right here, they have a variable in the denominator. Okay, that's what causes a rational function. Now let's get down to the gritty of graphing them. Please take out, you got these notes, and here we go. First thing we do is graph a basic function. Okay, so just as I put these numbers in the graph, what do I get? Negative 1/3. Negative 1/2. Now I plug in negative 1 and get negative 1. Now let's do this together. We have y equals 1 over negative 1/2. Well, calculate this. It's the division of fractions, and I take the numerator, I multiply it by the flip of the denominator to get negative 2 times negative 2 over 1 is negative 2. All right. When I plug in 0, here's an error, right? Because if I put 0 in the denominator, it doesn't exist, and that causes an asymptote for me. Okay, asymptote. All right, if I put in 1/2, I get over 1/2, same situation as above, multiply by the reciprocal, and you get positive 2. I plug in, I get y equals 1. I get y equals 1/2. I plug in 3, I get y equals 1/3. So let's graph that. Negative 3, negative 1/3. Negative 2, negative 1/2. Sir, this is farther away. 1, negative 1. Negative 1/2, negative 2. We don't at 0. Asymptote. 1/2, 2. 1, 1. 2, 1/2, 1/3. Okay? And what we see happening here is our rational function. We just saw there's a rational parent rational function. So this is the parent. Okay? And what we is if we have equal asymptote at x equals 0. X equals 0. We have a horizontal asymptote at y equals 0. So vertical asymptote, x equals 0. Horizontal asymptote, y equals 0. Vertical, horizontal. Now, the domain. The domain numbers, negative infinity to positive infinity. Negative infinity to 0. Soft bracket, doesn't include 0. United with 0 to positive infinity. That is how we write all real numbers. And the range is the same thing. It's all real numbers except 0. But it's referring to the y's, all real numbers except 0. Okay? So that's the parent. Now let's go through the nitty-gritty of how to graph. It's really detailed, so hang in there. Here we go. We have a different process. This is really important. What do I do to get this? What do I do to get this? All right? Vertical asymptotes. The process is finding the zeros of the denominator. Okay, I'm just going to shorten that word. Denominator. And what's the algebraic rule? Well, here's the general form, and here's a specific. Okay, in general, the rule is zeros of the denominator. Set the denominator, cx plus d, equal to 0. We would get negative f equals negative d over c number. Okay, in the real example here, the real function, let's set the denominator. 6 minus 5 equals 0. Then x will equal, add the 5, divide by 6, 5/6. Okay? So be my vertical asymptote. Okay, moving on to asymptotes. Horizontals, the process to find them, we call this HA generally in this vertical asymptotes, is dividing coefficients. Divide the leading coefficients. Okay? We notice that the numerator and the denominator are a function, two functions divided. So the leading coefficient in our general form, so it would just be y equals, right? So it's y equals a over c. In our example over here, it's y equals 3 over 6, or y equals 1/2. Okay? Very important that we realize that we have a vertical line, horizontal line. Okay? And that's the horizontal. All right. Now back to things we know, very well familiar with, x-intercepts. This is the zeros of the numerator. Okay? X-intercept. We set y equal to 0. So in a sense, what we're doing is we're taking the numerator, ax plus b, setting it equal to y is 0, and we're finding out what x is. And x would be negative b over a, but meaningless. Let's look at the real example. We take the numerator, 3x plus 1. We set it equal. We get x equal 1/3. Okay? Now, this is an intercept, so it has to be a point. So the x is negative 1/3. What did we do? We had set y to 0. That is intercept of the graph. Okay, moving on to the y-intercept. Well, what do? We set x equal to 0. And we find y-intercept is. The process here is plug in for and solve it. So in my general is y a times 0 plus b over c times 0 plus d. A number, b over d. So let's do it in our example. Okay, we're going to plug in 0. So we get y equals 3 times 0 plus 1 over 6 times, minus 5. And then we just do the math. 0 plus 1 is 1. 0 minus 5 is negative 5. So we got a y-intercept of negative 1/5, but it's a point, remember. So x was 0, y 1/5. That is our y-intercept. Right, domain. We've already talked about domain. The process of finding the domain is basically, it's easy. All real numbers, the vertical asymptote. Okay, and so that would be, found was negative dc. So I'm not even going to worry about writing this. It's just some number. Let's do the real example. Up here, we've got a vertical asymptote of 5/6. So our will be negative up to 5/6, the vertical asymptote, united with up to positive, okay? So the range is all real numbers except the horizontal asymptote, okay? And we do our example. What's our horizontal asymptote? Let's go get it. 1/2. So range will be negative infinity, but 1/2 united with 1/2 to positive infinity. And it just means all this number, okay? When you're graphing, you're going to find all these things, and then you're also going to draw points, okay? Extra points. Next page. To fully graph that isn't the parent. Okay, so let's turn the page and see and do a real live example. So we are going to graph x plus 4 over 8. So what we do is, let me get a highlighter. First, vertical and horizontal axis. Then we're going to plot the x, find the x and y intercepts and plot them. Now here's where we come to extra points. We're going to plot 2 points to the left of the vertical asymptote and 2 points to the right. Okay? Then we're going to draw the thing, and then we're going to find the domain and range. Okay, so here we go. Vertical and horizontal asymptote. Vertical asymptote. The denominator equal to 0. X minus 3 equals 0. X equals positive 3. Draw that. I go over to my graph. I find x equals 3. I'm going to draw a dotted line. I'm going to label x equals 3. There's my my vertical asymptote. Now I'm going to do my horizontal. Horizontal asymptote equals. Well, y equals the coefficients of the function, which the first coefficient is 1x over 1. So take your ruler, go to y equals 1, and draw a horizontal. Okay? Y equals 1. Coefficients of the function. The backbone of your graph. X and y intercepts. Okay? So x intercepts. Well, we said x were the zeros of the numerator. We set the numerator. X plus 4 equals 0. X equals negative 4. So our x intercepts negative 4, 0. Okay, let's go plot that. I'm going to plot that in orange. So negative 4, 0. There it is. There's an x-intercept. Now we've got the y-intercept. How do we find the y-intercept? We set x equal to 0. So we have y equal in 0. 0 over 0 minus 3 will equal negative 4, negative 1 1/3. My y-intercept, well, let's write it down, is going to be x was 0, y was negative 4. Okay? So let's plot that. 0, negative 1 1/3. So it's right here. Okay? Now we're talking extra points. Okay? Extra points. And this is probably the most tedious and the place we make the most mistakes, probably. Think carefully about this. So extra points, you need some space. Okay? What you need is you need a table x, y. Okay? And what are we going to do? 2 points left of the vertical asymptote. Vertical asymptote right in the middle. Asymptote is 3, so put the 3 right in the middle. Now this is going to be an asymptote, so it's not anything, it's the asymptote. 2 points lower, so we say 2, 1. We want 2 points higher, so say 4, 5. That's the tediousness. Here we go. We're going to plug these values into our equation. Y equals plus 4 over 1 minus 3. Do the math. 5 over negative 2, which is negative 2.5. Negative 2.5. Do it again. Y equals, plugging in 2. 2 plus 6 over negative 1, which is negative 6. There it is. Plugging in 4. 4 plus 4 over 4 minus 3 equals 8. Put that. If I'm going too fast, just stop the tape and make sure you've got good notes here. Y equals 4 over 5. You get the idea. 9 over 2. That's 2.5. So, I've got my extra points. I'm going to go up here and graph, right? Now, I'm thinking to myself, these points I know, so I know the graph is going to be here and here. So, if I get points here, I've done some wrong math. Okay? So, x is 1, y 2.5. There's a point. X is 2, y is negative 6. There's another point. X is 4. X is 8. Ooh, that's nice. Exactly where I'm expecting it to be. X is 5. 3, 4, 5. 2.5. There we go. Okay. See? Notice I have 4 points here and 2 points here. Because I can graph with 2 points. Here's what I'm going to do. No, I'm going to turn them. But I'm going to connect the dots and approach the asymptote but never cross it. I'm going to asymptote but never cross. But I've got more points. I'm going to connect all these pretty points and approach the asymptote. I'm almost done. So it's a beautiful graph, and I've got to state the domain and range. So, okay, all real asymptote. So negative infinity up to 3, soft bracket with 3 to positive infinity. There's my domain. All real numbers except 3. My range is all real numbers except my horizontal asymptote, which is 1. There it is. So negative infinity up off bracket united to positive infinity. All right, there it is, graphing rational functions. So please then come in and check that you did it correct. When you were graphing, you're gonna, you know, it's like a point for 8-point problem, right? Horizontal, vertical, x and y intercepts, extra points, domain and range, doing, okay? So make sure you've got all the elements. Good luck on your tests, and I'll see you when you get back.